Every story has a beginning. Every civilization, every mountain, every star, even every human life, which raises a question we've almost never stopped to question. Did the universe have one too? For nearly a century, science has given us the same story, nearly 13.8 billion years ago. Our observable universe emerged from an extremely hot, dense state that we call the Big Bang. It's one of the greatest scientific discoveries humanity has ever made. Ironically, its success has created one of its greatest misconceptions, not because the science is wrong, far from it, but because somewhere along the way, we quietly changed what the theory actually says. And in doing so, we may have hidden one of the greatest mysteries in modern cosmology, because the real mystery isn't whether the Big Bang happened. The evidence supporting an early, hot, dense universe is overwhelming. The real mystery is whether the Big Bang was ever the beginning at all. And to answer that, we're going to do something scientists have done for generations. We're going to follow the evidence. Let's begin with the image almost everyone carries in their mind. A tiny point. A colossal explosion. Matter blasting outward into empty space. You've probably seen that image your entire life. There's just one problem. That isn't what astronomers discovered. The Big Bang wasn't an explosion inside space. Space itself expanded. You've probably seen the balloon analogy before. It's useful. Just remember, our universe isn't literally the surface of a balloon. It's simply an analogy that helps us visualize expanding space. Imagine tiny dots painted across the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. Not because the dots are crawling across the rubber, but because the rubber itself is stretching. That's much closer to what astronomers actually observe. Galaxies appear to move apart because the fabric of space itself is expanding. That idea wasn't accepted because it sounded convincing. It was accepted because nature left clues. The first clue, galaxies are moving away from one another. The farther away they are, the faster they appear to recede. Then came another clue. Scientists discovered a faint glow filling every direction in space. The cosmic microwave background. The oldest light we can observe. A snapshot of the universe when it was only about 380,000 years old. Think about that for a moment. That ancient light has spent more than 13 billion years crossing the cosmos, only to end its journey inside telescopes built by a species that has existed for only a tiny fraction of cosmic history. Then came another clue. When scientists calculated how much hydrogen and helium should have formed in the early universe, their predictions closely matched what astronomers observed. 3 independent clues. 1 extraordinary conclusion. The universe really was once much hotter, much denser, and much smaller than it is today. At least, that's what most people think is the end of the story. It isn't, because every clue we've examined tells us what happened after the universe reached that hot, dense state. None of them tell us whether that state was the true beginning, and that's where the investigation takes an unexpected turn. So, let's keep following the evidence. Imagine rewinding the history of the universe. Galaxies drift closer together, stars disappear, atoms can no longer exist. Light itself becomes trapped inside a universe that is unimaginably hot and dense. Keep rewinding earlier still. As we rewind toward the very first moments of cosmic history, our understanding begins to unravel. Physicists call this the Planck epoch, and this is where something remarkable happens. The trail goes cold. Not because the universe disappears, because our mathematics reaches its limit. General relativity describes gravity and the large-scale universe with astonishing accuracy. Quantum mechanics describes the microscopic world with equal precision. But here, they stop speaking the same mathematical language. Not because either theory is wrong, because we've reached the edge of our current map. Again, the equations return the same answer. Infinity, infinite density, infinite temperature, infinite curvature. To a physicist, that isn't usually a satisfying answer. In physics, an infinity is often less a destination than a warning sign. not proof that nature itself contains infinities, but evidence that our current theory has reached the limit of what it can describe. As physicists traced the universe back toward its earliest moments, they realized our current theories could no longer describe what happened with confidence. Today, many wonder whether it was our mathematics that had reached its limit instead. This isn't where science stops. This is where the evidence ends, and the mystery begins. Somewhere beyond that boundary may lie the missing piece that explains how every galaxy, every planet, every atom in your body first became possible. So, what do scientists do when the map ends? They keep searching. And the first place that search leads is one of the most fascinating ideas in modern cosmology. When scientists reached the edge of known physics, they faced an uncomfortable possibility. Maybe the universe wasn't behaving strangely. Maybe our equations were. Instead of asking, what happened at the singularity, scientists began asking, what if there never was one? That question gave rise to one proposal known as the quantum bounce. Instead of the universe collapsing forever into an infinitely small point, quantum effects may eventually become powerful enough to halt gravity's relentless collapse. Imagine a universe collapsing for billions of years. Galaxies merge, stars disappear, space itself continues to shrink, gravity grows stronger and stronger, until, according to this proposal, quantum physics pushes back. The collapse stops, not with an ending, but with a transition. The universe reaches an unimaginably dense state. Then, instead of ending, it expands again. Our Big Bang wouldn't be the beginning, it would be the rebound. Think about what that means. Everything you've ever known, every person who has ever lived, every galaxy stretching across the observable universe, could exist because another cosmic chapter came before ours. If this proposal is correct, our universe may not be the first page of reality. It may simply be the latest one. But if a universe can bounce once, what would stop it from bouncing forever? That simple question has led some cosmologists to consider an even more astonishing possibility. Perhaps the universe doesn't experience just one bounce. Perhaps it has been renewing itself, again and again, for longer than we can imagine. In this picture, the universe isn't a single story. It's an endless sequence of cosmic chapters, each expansion followed by transformation, each transformation giving rise to another expansion. Some versions of these models suggest that every cycle leaves subtle traces behind, small fingerprints, that future observations might one day detect. Others propose that each cycle begins almost completely fresh, making previous universes forever hidden from view. At the moment, the evidence isn't strong enough to tell us which, if any, of these ideas is correct, but that's exactly how science works. Scientists don't create hypotheses because they sound exciting. They create them because the evidence leaves important questions unanswered. And so far, one question still refuses to go away. Was there ever a first beginning, or has reality always existed, changing from one form into another? If that's difficult to imagine, you're not alone. Because the next possibility may be even stranger. There's one final possibility, and it begins somewhere we already know exists. And unlike the others, it begins with something we know exists: black holes. For decades, they were thought to be cosmic dead ends, places where matter, light, and perhaps even information could never return. But some physicists have wondered whether that picture is incomplete. What if a black hole doesn't simply end in a singularity? What if, under the most extreme conditions, it becomes the birth of a new expanding region of space-time? If that sounds familiar, it should, because that expanding region would look remarkably similar to what we call a Big Bang. If this proposal were somehow correct, our observable universe could itself be the interior of a black hole that formed inside another universe. It's an astonishing possibility, but it's also important to be clear. Today, there is no direct observational evidence confirming this idea. It remains speculative, Yet it demonstrates something remarkable about modern science. The deeper we investigate reality, the stranger reality appears willing to become. We began this investigation with a simple question. Did the universe have a beginning? Today, the evidence gives us an extraordinary answer. The Big Bang explains how our observable universe evolved from an early hot, dense state. But whether that state marked the absolute beginning of reality remains one of the greatest unanswered questions in science. The universe has answered many of our questions. The remarkable part is how many better questions it has given us in return. Perhaps that's the true lesson of science. Every discovery expands the boundary of what we know and reveals a new frontier beyond it. Until next time, let's keep following the evidence.